We're going to solve this system by using the elimination method. The first step is to get your equations where your x's, y's, equal signs, and numbers are all lined up. And so that means also putting these equations in standard form. This first equation is not in standard form. 2x equals 3y minus 5. Standard form has the x's and the y's on the same side, so if I subtract 3y from both sides, I get 2x minus 3y equals negative 5. Now that's in standard form. The second equation is already in standard form. And what we want is either the numbers in front of the x's to be opposites or the numbers in front of the y's. I'm going to choose to work on the y's because this is already negative and this is already positive. So then we look at the 3 and the 2 and we say, what is the smallest number that both 3 and 2 divide into? Well, that would be 6. So what do I multiply the top equation to make that a 6? Multiply it by 2. What do I multiply the bottom equation to make that into a 6? Multiply that by 3. So the top equation now looks like 4x minus 6y equals negative 10. The bottom equation becomes 9x plus 6y equals 36. Now notice that the numbers in front of the y's are opposites, so if I were to add each of these pieces straight down, these negative 6y and positive 6y would be eliminated. So 4x plus 9x is 13x. That drops out to 0. 36 plus negative 10 is 26. I can now solve this equation for x by dividing both sides by 13. And I get x equals positive 2. I want to take that 2 and find out what y is. I could plug it pretty much anywhere in. Our book suggests you plug it back into one of the original equations. So I'm just going to plug it back in for the x in that equation there. And what I will get is 3 times, now instead of x it's equal to 2, so 3 times 2, plus 2 times y equals 12. That's 6 plus 2y equals 12. Solving, subtract 6 from both sides of the equal sign, 2y equals 6, and then divide by 2 here, and I get y equals 3. So now I have my solution is x is 2, y is 3, and I want to do the check step. So here's our check. I'm going to check by plugging that 2 in for x and 3 in for y into both of my original equations here. So that's going to be 2, and then plug a 3 in there. So the check step looks like 2 times x, which is 2, should equal 3 times y, which is 3, minus 5. So 4 should equal 9 minus 5, and 9 minus 5 equals 4, so it checks in the first equation. Don't forget, you must check in both equations. It has to make both equations true in order to solve the system. So plug a 2 in for that x, plug a 3 in for this y up here, and show that 3 times 2 plus 2 times 3 should equal 12. 3 times 2 is 6, 2 times 3 is 6, 6 plus 6 is 12, and that checks as well. And you're done.